Hey guys, welcome back to my channel. Today we are going to talk about the kernel. In an operating system, the kernel is the core component that provides the basic services for all other parts of the OS. It is the most fundamental level of software that interfaces directly with the hardware of a computer. The kernel is responsible for managing system resources and allowing software to interact with the hardware. When you power on your device, the firmware, which is BIOS, the basic input output system, springs into action, ensuring that all the hardware resources are in order through a process known as post. What is post? Post is process of self-test where the firmware basically makes sure that this process post runs, which will check all your hardware resources and make sure that it's all working fine. Following this, the bootloader, it's a small software program that takes charge. Its job is to locate and load the kernel image stored on the disk. It will hold it in the memory throughout the lifespan of the operating system. Once the kernel is loaded, the kernel initialization commences. The CPU's operation mode is set, device drivers are initialized, interrupt handlers are prepared, and system processes are created. Hardware devices and the corresponding drivers are detected and initialized, ensuring seamless interaction between software and hardware. The kernel then mounts the root file system, granting the operating system to access crucial files and directories stored on the storage device. After the file system is mounted, the kernel starts the first user space process, typically known as init. In certain cases, it's also called as systemd or upstart. So these are basically the first daemons or the first processes that gets initialized. This process is responsible for starting all the other user space services and processes which are required to run the system, such as system daemons, networkings, and the GUIs, and etc. Whatever is required, uh, you know. So let's say you start your laptop, right? The first thing you'd see on the screen when you open the laptop or start the laptop is you see a login prompt, right? So this login prompt can be considered as the init process, okay? Or it could be, it's an equivalent to systemd. The system will typically present a login prompt either on the command line or through a graphical interface. Okay, this is the init process which has been set up in the user space environment. Okay, apart from this, the other objectives of the kernel is to establish communication between user level application and the hardware. It's also used for process management. It is used to control the disk management. It is used to control the memory management. So these are the objectives of the kernel. Apart from kernel initialization, it also does the resource management. So let's talk a little bit about the user space and the kernel space. The user space and the kernel space are two distinct regions of memory in the context of operating systems that separate the user level applications from the core operating system functions. This separation is crucial for security, stability, and efficiency. Okay, so what is the user space? The user space is a location where normal user processes run. That is everything other than the kernel. The role of the kernel is to manage applications running in this space. Okay, the kernel space, which is the location where the code and the data of the kernel is stored and executes under this space. So the code which is running in the kernel space has very high privileges. It has unrestricted access to the hardware and all the system resources. Okay, the kernel performs tasks such as managing memory, scheduling process, handling system calls, managing the file systems and devices input output. Because of high level of access, a bug or a security vulnerability in the kernel can lead to severe system instability or security breaches. Therefore, the kernel code is highly privileged and must be trusted. Now, the user space is the memory area where user applications run. These applications are restricted in what parts of the hardware they can access directly. Applications running in the user space must communicate with the kernel through well-defined system calls to request privileged operations like accessing the hardware or memory locations. Then there are something called as interrupt handling, and appropriate interrupt is associated with the action, and that's how the kernel responds to all the system calls. So we will talk about the system calls and interrupt handling in the next video. Then this code in the user space runs with very low privileges. It's very restricted, which means that in terms of system resources it can access and modify. The separation between user and kernel space provides an important layer of security because it prevents the user applications from directly manipulating hardware or kernel data, which could cause system instability or security vulnerabilities. Okay, so now that we know about the kernel space and user space, there are different types of kernels which were developed based on this concept. One of the most earliest kernels were monolithic kernel. Okay, so in this we have only kernel space and we don't have user space. Both application and the kernel are running in the same space, so there is less context switching between this, since both are running in the same space, right? Both kernel and the application is running in the same space, so less context switching. That means it's more faster, it's more reliable, but it's not secure, right? Let's say you write an application and that application is trying to access a hardware resource or some memory space in the kernel, and you would be able to modify it, and that could lead to certain crashes. It could also it's very vulnerable to security breaches. So monolithic examples of this type of kernel is Linux and Unix. Okay, then we have the second type, which is called microkernels. In microkernels we have a user space and a kernel space. Since we have the application in the user space and the kernel space in a different space, there has to be a lot of context switching, and therefore it is less faster, but since both are separated it's more secure. Only some important components like inter-process communication, uh, basic process scheduling and management, and memory management happens in the kernel space. Everything else is in the user space. Some of the examples of microkernels is QNX and Herd OS. Then comes the hybrid kernels. It's basically a combination of monolithic and microkernels. Okay, again over here we have a user space, a dedicated user space, and a dedicated kernel space. In the kernel space we have the IPC, we have the basic scheduling, we have the memory management, we have a few more uh, operations which we can do over here, that is network space, device drivers, and file systems. Okay, all these are run in the kernel space and the rest of them is in the user space. So there is a clear bifurcation between the user and the kernel space, and this leads to fewer context switching, but we still have it, but it's a little faster, it's also more secure and more reliable. It's kind of a trade-off you have to choose in your while designing an operating system. Do you what do you want more, security or speed and performance, right? So you have to come to a middle ground, and hybrid kernel is one of those types of kernels which does that. And the two examples I can give you is Mac OS and the Windows OS. They use hybrid kernels. Now we have a few more types of kernels like exokernels, nano kernels, unikernels. I'll share a link with you guys. Please just read through it about what these different kernels do. But the objective of understanding the user space and the kernel space will help you decide what kind of a kernel you guys should be developing. What are its trade-offs, what are its advantages, and what are its disadvantages? If you have an idea of this, then you will be able to design a kernel based on your needs. where in case if performance is important to you, then you go for monolithic. If security is important for you, you go for microkernels. If you want best of both worlds, then you go for hybrid kernels. So in addition to the kernel, an operating system consists of several other essential components that work together to provide a seamless computing experience. We have the shell, which could be the interpreter command which is entered by the user and executes them by communicating with the kernel. It's basically like bash or powershell. Then we also have the UI. We have system services. These are like the background processes that performs various tasks such as managing network connections, handling certain jobs, providing security features like authentication and access control. Then we have specialized programs which are called as utilities by the OS, which perform specific tasks such as system maintenance, troubleshooting, performance optimization, etc. Then there is the networking stack, which enables communication between computers and devices over a network. It includes protocols and services for sending, receiving, and routing data packets across networks. So there is a security subsystem. So all these components work together seamlessly to provide users with a functional and reliable computing environment. So this was about the kernel. So please do let me know in the comment sections if you guys have any questions. Please like, share, and subscribe. Thank you.